Procedures for testing hypotheses about location parameters, sign test for two related samples. Learning outcomes for this topic is, after studying this topic, students will be able to use the sign test for two related samples to make inference about location parameters. Sign test for two related samples, which is, it is particularly useful if the measurement scale is only ordinary. Also, it can determine only whether one is larger than the other, and if so, which is larger. The assumptions: firstly, the data consists of a random sample of n pairs of measurements where x1, y1, x2, y2 until xn, yn, where each pair of measurements is taken on the same subject or subjects that have been paired with respect to one or more variables. The variable of interest is xi minus yi equals to di, which is di is the difference between pairs of measurements. Secondly, the n pairs of measurements are independent. Next, the measurement scale is at least ordinal within each pair so that one can determine which of two members is larger unless they are equal. Lastly, the variable under study is continuous. In sign test for two related samples, it consists of three cases, which is case A, case B, case C, which is case A is two-sided case. The hypothesis of case A is H0, MD equals to 0, H1, MD is not equal to 0. For the test statistic, either a sufficiently small number of plus sign or a sufficiently small number of minus sign cause us to reject H0. The number of plus sign or minus sign which is smaller. For the decision, we will reject H0 at the alpha level of significance if the value of the binomial probability distribution table is less or equal to alpha over 2, since k is the number of plus sign or minus sign which is ever is smaller, and n is the sample size. Since this is two-sided case, therefore alpha must be divided by 2. For the case B, one-sided case, the hypothesis is H0, MD is less or equal than 0, H1, MD is greater than 0, and for the test statistic, if small number of minus signs causes to reject H0, therefore the K is the number of minus sign. To make decision, we will reject H0 at the alpha level of significance if the value of binomial probability distribution table is less or equal than alpha. Next, case C, which is one-sided cases. Hypothesis H0, MD greater or equal than 0, H1, MD less than 0. And for the test statistic, if small number of plus sign causes to reject H0, consequently, K is the number of plus signs. For the decision, we will reject H0 at the alpha level of significance if the value of binomial probability distribution table is less or equal than alpha, where K is the number of plus sign and N is the sample size. Also, we will record plus sign if xy minus yi is greater than 0, or record minus sign if xi minus yi is less than 0, and if xi equals to yi for any pair, eliminate those pairs from the analysis and reduce n accordingly. Let's see the example. Layton and Keppel studied the effect of togetherness on heart rate in rats. They recorded the heart rates of 10 rats while they were alone and while in the presence of another rat. The authors, who used a t-test with the data, were able to conclude at the 0.05 level of significance that togetherness that in rats increase heart rate. Let us see whether we can reach the same conclusion by using the sign test. Let alpha equals to 0.05. For the solution, first we have to making the hypothesis. The hypothesis for this example is H1 MD greater or equal than 0, H1 MD is less than 0, which is H1 is the claim. We know that H1 is the claim by the clue from the question, which is rats increase heart rate. Therefore, we know that H1 is the claim. Second, find the test statistic. From the data given, it has X samples and Y sample. First, we need to find difference of X and Y, which is Xi minus Yi. Then, we state the sign of the difference of Xi minus Yi. Since the example is the Kc, therefore, the K is the value of the plus sign. Since plus sign consists of 2, therefore, K equals to 2. And we know that N equals to 10, and given that alpha equals to 0.05. Next, find the p-value. To find the p-value, we need to refer table A.1. We know that N equals to 10, K equals to 2, and given that 0.5. From the table, we found that the p-value is the summation of all these values. Since we only take 4 significant figures, the p-value is the summation of 0.0010 plus 0.0098 plus 0.0439 equals to 0.0547. Therefore, the p-value is 0.0547. Then, make a decision. Since p-value is greater than 0.05, so do not reject H0. Therefore, the conclusion is do not have enough evidence to support the claim that togetherness in rats increase heart rate. Now, let's try for some exercise. Exercise 1. Exercise 2. And exercise 3. Try this and I wish you good luck.